Hey, today we're going to talk about 7.3, thermal inversions. So take a moment, check out the enduring understanding, look at the learning objective, pause the video, review the essential knowledge, and set up your Cornell notes. So thermal inversion is related to the heat island effect. And an urban heat island, remember, there are a lot of surfaces in a city that have very low albedo. In other words, they absorb a lot of solar energy and in turn re-radiate that energy as infrared radiation. In other words, the sunlight makes the cities hotter. Okay, we have all these dark surfaces, the roofs of buildings, we have the pavement, the concrete, all of those surfaces absorb the radiation. So it increases the temperature a lot, and it will increase the temperature when you have vegetation, but it will increase the temperature a lot more when you have other surfaces, like for example the asphalt and the concrete and the buildings. So what happens is you have the warmer air is trapped closer to the surface, and as you increase in altitude, what happens is you lose a lot of that infrared radiation, or you lose that heat. And this is what normally happens. It gets really hot during the day, especially if you think about the summers in New York. It gets really hot during the day, and at night it cools off because that warm air, remember, it's less dense than cool air. That warm air will rise. So in a normal setting, you have a lot of pollutants that are building up here in a city because you have a lot of combustion of fossil fuels. So in a city like New York, you have this warm air, and at night the warm air starts rising and takes with it the pollutants. So this is actually something that helps to basically kind of like reset and clear the air in New York, especially if we have some really poor air quality days. Now, something might happen where you have what is called a temperature inversion. And instead of having the warmer air on the bottom and the cooler air on the top, or as higher up in altitude, there may be an inversion where you have a little thin or thinnish layer of warm air that's sandwiched in between cooler air. And what happens is you still generate all of the same pollutants, but at night, the pollutants get trapped. And they get trapped in this temperature inversion, and they get stuck, and the pollutants are not able to dissipate farther into the atmosphere and out into space. So one of the things that happens is these temperature inversions can keep all of these pollutants, keep the photochemical smog, all of this stuff keeps it nearer to the surface, and it keeps it in close proximity to the air that we breathe. This is very common and commonly seen in areas where you have a valley between two mountains. So this could be a geographic cause. And if you have a valley, it's very difficult to mix up this air. So thermal inversions or temperature inversions show up a lot in valleys. This happens in, for example, a city like Beijing. And you have all the pollutants that are still building up, and at night they get stuck in the atmosphere, so they're closer to the surface, and people are continuously breathing in this poor quality air. This also can happen in coastal areas, and this is what it looks like in a place like Los Angeles, where you have the same, you may have a geographic feature like a mountain, but you also may have the ocean. So typically you'll have an area of high pressure, which is keeping this warm air, this inversion, it's keeping that inversion intact. And then you'll also have air blowing off of the ocean. So it's blowing the air towards this mountain, which it can't go anywhere. It's also got this high pressure pushing down, so you're pushing from multiple angles. That air cannot travel and cannot move anywhere. So the key points to this for a thermal inversion is you have a layer of warm air that's trapping the cooler air beneath it. And with that air that gets trapped, you have pollutants also getting trapped. And this often occurs in valleys or something where you have some sort of geologic feature like a mountain. All right, for your FRQ practice, I would like you to explain how the arrows relate to the air quality in each scenario. So take a moment. I look forward to seeing your responses. I thank you very much for your attention. I hope this was informative. I will see you soon.